Why does light cause a tattoo to fade? This simple question has huge implications, as laser tattoo removal is a $4+ billion a year industry. Surprisingly, despite the growing number of tattoos and the increased need for laser removal, we don't actually understand how laser tattoo removal works. One way we can try to understand the process is by using shadows. Just like you can use your hands to create shadow puppets on the wall, we use shadows in a technique called nanosecond shadowgraphy to study how laser tattoo removal works. We zap tattooed samples with a very bright laser pulse from a nanosecond laser to simulate laser tattoo removal. Immediately after that first pulse, we shine a second laser pulse at the spot where the first laser pulse hit. The explosion from the tattooings creates a shadow that we can see with a very fast camera. Here, you can see the sample before being zapped by the laser, and then 124 nanoseconds after the laser pulse, showing an explosion of the tattooing and the formation of a shockwave. From that, we can figure out how hot and how much pressure the laser creates when it hits the tattoo. In order to perform nanosecond shadowgraphy, however, we need to be able to get light through the sample, so we can't use actual skin. Instead, we have developed transparent mimics of skin using polydimethylsiloxane, or PDMS, a type of plastic that can mimic the mechanical properties of the different layers of skin. We can tint the artificial skin to show the different layers that mimic the epidermis, the dermis, and the hypodermis. This artificial skin can be tattooed and zapped by a laser for either shadowgraphy experiments, or sliced apart after exposure to the laser to study what happens to the tattoo pigments after being zapped. We also tattoo real human skin from cadavers, and then zap that skin with a laser to study the process of laser removal. By slicing the skin into thin slices, we can use microscopy and other techniques like Raman spectroscopy to understand how the tattoo pigments sit in the skin and then break down when exposed to laser light. Finally, we also use lasers to break down tattoo pigments by themselves. Here, you can see a sample of pigment yellow 74 that photodegrades into new, red-colored compounds when exposed to a laser. We can separate all the different breakdown products and use a variety of techniques like mass spectrometry and nuclear magnetic resonance spectroscopy to determine what the breakdown products are and if they pose a potential risk to human health. In the near future, we hope that answering the question, why does light cause a tattoo to fade, can lead to the development of new, better tattoo removal methods and a deeper understanding of how tattoos behave and change in the body.